evening. I'm Spot On Weather meteorologist Matthew Euler, and welcome to the sixth and final part of the Spot On Weather 2022-23 winter forecast. This title tonight is The Final Verdict. So taking into account everything we've discussed, the past 5 videos of the whole winter forecast series, I'm finally ready to delve into my reasoning for the final forecast, as well as the final maps. So let's go ahead and take a look at things this evening. Funny little picture here to start tonight's video. Have you ever had a dog that just kind of tilted his head to the side like this? So I thought this was pretty funny. We got 3 of these dogs just kind of doing at the same side too, as certain sounds certainly make dogs tip their head to the side. So will your head look like this at the end of the video after I give you the final verdict? Well, we'll find out, won't we? All right, so the first thing I'm going to mention, and this is always a challenging forecast. That's the first thing I'm going to start this session off with. Seasonal forecasting is very challenging, and these are some of the reasons why. The top bullet there, the title of the slide, basically says, which is most dominant this winter? Will it be the Pacific side in the form of La Nina, the Madden-Julian oscillation, that enhanced cloudiness and convection in the Pacific side and the Indian Ocean side? Will it be the Pacific Decadal oscillation, that PDO we talked about in a previous video? Will it be the Eastern Pacific oscillation, that EPO? Or will the Atlantic side dominate this winter season? The AMO? What about the Indian Ocean dipole, the IOD? The Arctic? Could the AO and the NAO, as well as that stratospheric polar vortex, whether it's weakened or strong, will those be the dominant factors this winter season? And then these questions just kind of come to my mind whenever I analyze and look at all these potential impacts for the winter season forecast. How do these all together impact the long wave pattern, that jet stream configuration? And for how long? What's the duration of this? And what particular spatial area, what spatial domain are we talking about? Additionally, we could see a winter to where, maybe it's a combination of both sides, the Pacific and the Atlantic side, or maybe the Atlantic side and the Arctic. Does one of these teleconnections above or climate drivers dominate certain parts of the winter and another takes over later? And additionally, I've talked about this before in past videos, constructive interference versus destructive interference. A constructive interference situation is when I have 2 of these teleconnections or climate drivers working together, kind of enhancing each other. Whereas destructive interference is an out-of-phase relationship in which one teleconnection indicates one thing and the other teleconnection something completely opposite. Again, this makes seasonal forecasting so very, very challenging. Here is my just general blurb about the constructive and destructive interference, a little bit more in depth. At times, these teleconnections work together in one direction, as I just mentioned, in more of an amplifying manner, and that's that constructive interference. Here's some examples up here of constructive interference, where we have a negative North Atlantic oscillation, a negative Arctic oscillation, and a positive PNA. All 3 of these would work produce a very similar outcome. They enhance each other. At other times, the teleconnections actually work against each other in opposite directions, and that is known as the destructive interference. This is the out-of-phase relationship between the teleconnections. An example would be a negative North Atlantic oscillation, but then we have a trough along the U.S. West Coast, and we have what's known as a negative Pacific North American pattern. Okay. So since some of the most extreme winters, by the way, whether they've been exceptionally warm or cold, have been associated during these constructive interference in-phase scenarios of the teleconnections. I can think back to the 2010 winter in which the NAO was strongly negative, the AO was strongly negative, so they kind of enhance each other. Additionally, we had a strong upper level ridge parked over the U.S. West Coast. So in general, what I'm getting at here is certain teleconnections can also be stronger and more dominant over others during the winter season. For example, a La Nina winter, we typically expect to see drier and milder conditions across the southern U.S., the southeast, up into the mid-Atlantic. But you know what? La Nina might be weakest of all the teleconnections. Maybe you get a strong negative NAO and high latitude blocking into the North Atlantic, and that pretty much overpowers the La Nina. So just because a teleconnection is supposed to produce certain weather, that's not always the case. For example, a couple of winters ago, El Nino never behaved like El Nino for the eastern U.S. And that's just another example. So taking a look at everything on the whole 5 video series I put together before this part 6, these are the forecast factors I looked at in producing the 2022-23 winter forecast. I looked at the Madden-Julian oscillation, the MJO predominant phase forecast. And what we're looking at is that relationship between the Indian Ocean dipole, the IOD, and how we have a negative IOD right now that generally tends to favor enhanced upward vertical motion around that Malaysia area, Indonesia area, right on over to the maritime continent. So the negative IOD right now actually favors, if you take the IOD and look at the MJO output, it's favoring an MJO phases through 5, which that would be above normal temperatures for the eastern U.S. this winter, if that was the case. Now, the amplitude of the phases of the MJO is unknown, and it's a very tricky thing to forecast. But yet they're very, very important. The further away and more amplified, the further away you get from the inner circle of that MJO phase diagram, the greater the potential impacts an MJO will have in the weather. Next, I looked at the PDO, the Pacific Decadal Oscillation, the forecast. And right now, we're looking at a positive phase. Now, a positive phase indicates above normal water temperatures in the eastern Pacific Ocean. And that's going to generally indicate, I showed that positive PDO look in my previous video. That indicates colder than normal temps for the eastern U.S. So we got one MJO that could potentially favor warmer than normal temps in the east. And then we have a positive PDO, which will favor colder than normal temps in the east. Now, La Nina, here's the big thing about La Nina this year. It's, number one, it's going to be working out of phase with the positive PDO. All right. So I basically look at both of these factors, the La Nina and that positive PDO. And by the way, the La Nina also is in a weakened state. It leads to less influence this winter is what I believe, with these two combined, La Nina plus that positive PDO. The Atlantic multi-decadal oscillation, AMO, I took a look at that and noticed that we had warmer than normal waters south of Greenland up in the North Atlantic, so it's in a positive phase AMO. That alone would indicate colder than normal temperatures in the eastern U.S. Then the Arctic oscillation and that North Atlantic oscillation. These are very tricky teleconnections, very difficult to forecast what they're going to do. The AO really ties in directly with the strength of that stratospheric polar vortex. But overall, what we're thinking, based on what we're seeing, in all of our studying of what's going on right now, some analog methods, we're looking at a negative phase predominantly of the AO this winter and more of a weakened stratospheric polar vortex. So that would favor colder than normal temps in the eastern U.S. as well. Additionally, the North Atlantic oscillation, the NAO, expecting a negative phase this winter for the most part due to the positive Atlantic multi-decadal oscillation, the positive AMO, those warmer than normal waters across the North Atlantic south of Greenland, and also a negative IOD, the Indian Ocean dipole. You combine the NAO with the AMO and the IOD, that all favors colder than normal temperatures in the eastern U.S. for this upcoming winter. Okay. Now, one thing I want to mention, even though we're forecasting a negative phase AO and a negative phase NAO, it's definitely not going to be negative the entire winter from December 1st to February 28th. It's going to go in and out of various phases. It will occasionally rise to neutral and positive phases, so this is the predominant forecast. Additionally, we look at the IOD. Now, if I just look at the IOD, the Indian Ocean dipole alone, it's in a negative phase right now. So that would indicate near normal temps along the U.S. East Coast. The stratospheric polar vortex, the SPV, expecting it to be primarily in a weaker state or a weakened state. That would favor colder than normal temps in the eastern U.S. Not really sure if we're going to see, that sudden stratospheric warming, a significant major sudden stratospheric warming lead to a split stratospheric polar vortex or just an elongated one. Remember I mentioned in my previous video an elongated polar vortex would favor more cold for the eastern North America, whereas a split polar vortex would favor colder than normal temperatures for Eurasia, Siberia, and Europe. So we'll just have to keep an eye on that. The Arctic sea ice, very similar to last September, last fall. So I'm not really taking it into account as much as a significant factor in this winter forecast this year. The Siberian snow cover, it's in an above normal stage right now. We're getting in that sweet spot in time in October where it really matters. Talked about refrigerating the overlying air mass. Right now it's above normal Siberian snow cover. We have colder than normal temperatures in the eastern U.S. if that's the case. That tends to lead to more of a negative NAO and also a more meridional jet stream, a weaker jet stream, colder temperatures with a trough in the eastern U.S. The volcanic activity, that one's really tricky this year. Excessive water vapor, as I mentioned in yesterday's video, in the stratosphere could result in a warmer surface temps here at Earth's surface, whereas particles in the upper atmosphere that were ejected from the volcano could result in cooler surface temps. Overall, what I'm expecting in the short term is for the Tunga volcano that happened earlier this year in January, I'm expecting those effects to even out this winter between the excessive water vapor, more of a greenhouse gas, and those particles. Solar activity, definitely projected to be more active as we're in solar cycle 25 now. And that more active solar disturbances generally leads to less blocking patterns, high latitude blocking patterns. So this would be one that kind of goes against the negative NAO, where we're seeing warmer than normal temps in the eastern U.S. and we have less blocking and more of a zonal west to east jet stream. But I'm not really anticipating the solar activity to be a major player in the overall weather outcome. Now let's get to the weighted forecast factors. This is really what I'm leaning on for this winter's forecast. We've already seen the positive PNA pattern set up with the ridge along the U.S. West Coast and up into Western Canada and that downstream trough into the central U.S., really the Midwest to the East Coast. And I really don't see many changes to the overall pattern. Sometimes the atmosphere likes to get into a pattern and it just continues to produce that pattern. Now there'll be times where that PNA is going to go negative. Okay, don't get me wrong. There's going to be times where we're going to have temporary pattern changes where you're going to get the trough in the western U.S. and the ridge popping up in the east. But I am predicting a majority of the time we'll see a positive Pacific North American or PNA pattern, ridge west, trough east, along with this negative AO and negative NAO. There's your constructive. That's your constructive interference, remember? We're expecting a weaker than normal stratospheric polar vortex and a positive Atlantic multidecadal oscillation, AMO, warmer than normal waters south of Greenland. That's going to contribute to a colder than normal winter across the eastern U.S. That's what I'm forecasting. I think La Nina, since it's in such weak territory, it's not even quite to a degree Celsius below normal in that Nino 3.4 region. In a weak state, it's not even in the moderate level, just below that threshold. And all of the climate models are forecasting La Nina to start transitioning to ENSO, neutral conditions, once we get into the new year in January and then leading into February, March. We're expecting ENSO neutral conditions to take over in the late winter. So I'm not factoring La Nina as heavily as I might if this was like going to last all winter season, as well as the intensity. If it was stronger, okay, I could bite off on that, La Nina being more of an impact. Now, there will be periods of milder temperatures from time to time. Don't get me wrong. I'm saying colder than normal across the eastern U.S. this winter, but there will be times in which we'll see a rebound in the temperatures like we always do. It's a balancing act in nature. The polar front jet stream will occasionally become more zonal west to east. Those deep troughs will move out and move to the northeast, and things will flatten. The jet will flatten in between these colder surges of air. I'm also expecting above normal precipitation from the Great Lakes area to New England, below normal precipitation across the Gulf Coast as well as the western U.S. underneath that upper level ridge. Now, these are my wild cards that could actually totally make this forecast go awry. The MJO phase and amplitude, I mentioned it already. If we get stuck in a warmer phases 3 through 5, December through February, and there's a great amplitude to this, we definitely could have a different outcome for the temperature profile in the eastern U.S. this winter. It could be milder. Volcanic activity, as much as I'm thinking it's going to even out between the excessive water vapor from the Tonga eruption, as well as the particles and all that tend to block out the incoming solar radiation, I'm really thinking it's going to even out. But let's just say that excessive water vapor does become the predominant greenhouse gas and traps the heat, and we have warmer than normal winter temperatures in the U.S. So that's something to watch as well. The stratospheric polar vortex, always a wild card every winter. We always look for clues or signs onto what this thing's going to do every winter. We really don't have the tools. We're not quite yet there for predictions of accuracy of the vortex and the stratosphere. If it's stronger than normal or anticipated, this could result in much milder temperatures across the U.S. with a highly zonal polar front jet stream, very similar to what I put here for the MJO. And additionally, La Nina influences early in winter. They could result in milder temps for the east, especially in December, if it tends to be stronger than what's projected. So that's just something we've got to watch too. Overall verdict is for a colder than normal temperatures across the eastern U.S. and warmer than normal temperatures across the western U.S. due to a persistent ridge west, trough east configuration. And I know you're anxiously awaiting to see my maps here, and here you go. For the temperature forecast for the 2022-23 winter season, I don't normally like to go this bold and cold across the east, believe me. We're expecting overall from the December 1st to February 28th, this ridge pattern to continue over the western U.S. and a downstream trough here in the eastern U.S. For the winter, expecting milder temperatures beneath the upper level ridge along the west coast. And by the way, I didn't draw it out and I was debating whether to or not, but there's a good possibility these above normal temperatures could extend further into South Texas as well as into parts of the Gulf Coast states further east here. I don't have that on here, but I put that kind of as a cautious statement there, especially at the start of winter if La Nina is stronger. I do expect to see frequent high latitude blocking situations over the western U.S. here, as well as into western Canada, and then other high latitude block over the North Atlantic due to the positive AMO, as well as the negative NAO. Okay, so this is my chart. You see above normal temperatures in the west, near normal temperatures in the central U.S., and then below normal temperatures for the east, really from the Midwest eastward to New England down to the Mid-Atlantic. As far as the precipitation forecast for the 2022-23 winter, this is what I'm looking at. Wetter than normal conditions there across, basically from the Great Lakes region across to New England. Below normal precipitation along the Gulf Coast, including the Florida Peninsula. Near normal precip for the Mid-Atlantic, as well as into the central U.S. and northern plain states. And then below normal precipitation, drier than normal across the western U.S. So what I'm expecting to occur is persistent troughing and the storm track kind of moving through here. We'll occasionally get some systems that will develop off the coast here and become nor'easters and kind of move up the coast. But this area in particular, New England, is going to be in that storm track, as well as we'll have the persistent troughing in the east. We do expect drier than normal conditions, again, like I mentioned, beneath this ridge in the west and along the Gulf Coast. And this is going to be attributed to La Nina. Okay? That's all I've got, everybody. This is the final verdict. I'm sticking with it. Like I said, I don't normally like to go this bold and cold over here, but I've been looking at this stuff for weeks now. All these factors, right? All of these: MJO, PDO, La Nina, AMO, AO, NAO, right on down the line. IOD, the stratospheric polar vortex, which that's very tricky to forecast for. Arctic sea ice extent, not really taking that into account much, very similar to last September. The Siberian snow cover, we definitely got to take a look at that. That's a factor. The volcanic activity, again, that's that wild card. Could go either way. And then the solar activity, not really expecting that to be much of a factor this winter season. But all of this stuff comes together, and this is my weight. I'm going with the PNA, the AO, NAO, stratospheric polar vortex, and AMO. I think La Nina, again, is going to weaken, transition to ENSO neutral by late winter. And that's all I've got, everybody. I really hope you enjoyed the winter forecast series. All right. Are you looking like these dogs? Hopefully you're not. Like, wow, I'm in amazement. He just put that out. All right. That wraps it up. We'll see how things go this winter. And you know what? I know I'm not right 100% of the time. And you know what? I will definitely dig deep into everything and take a look at it at the conclusion of winter to see if I was not right. I will go back and look at what went wrong. And that's the way you learn. You learn from, if you're not right, you definitely learn from those times. But this is the way I feel right now. I'm pretty confident in this forecast. And that's all I've got, everybody. I thank you so much for subscribing to the channel. And until next time, oh, by the way, I just wanted to mention that I'll be doing teleconnections, weekly teleconnection videos soon. And we'll start talking about the overall global patterns with the teleconnections and what that might mean for our weather. All right, take care, everybody. God bless everyone. Till next time.